Welcome to 2.8 Triangle Theorems. In this lesson, we're going to talk about theorems, different theorems, and examples. This is actually the last lesson for this unit. Okay, so first let's get into the isosceles triangle theorem. This states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so if it's hard for you to understand looking at the word form, I drew pictures. I think Apex does a good job summarizing this. So again, and I color coded it, as you can see. So if segment AB is congruent to segment BC, right, if two sides are congruent, then the angles opposite those sides, this would be angle A and angle C, because these are the congruent sides. So what is the angle opposite from this side? It would be this angle. What is the angle opposite from this side? It would be this angle. Okay, so then the angles opposite those sides are congruent. Okay, now those actually have special names. So the congruent sides are called legs, and the congruent angles that are opposite from the legs are called the base angles. So this theorem basically states that if two sides are congruent, then the angles opposite those sides are also congruent. Now let's look at the proof for the isosceles triangle theorem. So again, I just rewrote what the theorem states. Now, let's remind ourselves what the theorem states. It states that if two sides are congruent, then the angles opposite those sides are congruent. So what is the purpose of the proof? We want to prove the last part of the statement. Then the angles opposite those sides are congruent. So here's the figure given. We know that these two sides are congruent based on the hash marks drawn in the figure. We need to prove that angle A is congruent to angle C, okay? Because that is what the theorem states, so we have to prove it. So we're already given segment AB is congruent to segment BC, so it is one of our statements, and the reasoning is that it's given. What else do we notice? Well, for every segment, it has a midpoint. So for AC, let's draw midpoint D. Okay? So our statement would be draw midpoint D. And what is the reasoning? The reasoning is that every segment has a midpoint. Has a midpoint. And I'm just going to abbreviate midpoint, mid, PT. PT for point. Okay, now what do we notice? Well, remember midpoints, by definition, they divide a segment into two equal parts. So since D is our midpoint and it's dividing AC into two equal parts, then that means segment AD is congruent to segment DC. And we can write that as another statement. Segment AD is congruent to segment DC. And what is the reasoning? The reasoning is that midpoints divide segments into two equal parts. So we wrote the statement. Now let's also represent that on our figure with hash marks, okay? Okay, what else do we notice? Well, we know that for every 2 points, there is a line segment connecting them. See, we have point A and point B, and the line segment connects them. Point B and point C, and we have a line segment that connects them. Well, we also have point B and new point D, so there should be a line segment that connects them. So what's our fourth statement? Our fourth statement is draw segment BD. And what's the reasoning? The reasoning is that every 2 points, PT is just points, every 2 points has a line segment that connects them. Okay, now what else can we conclude? Oops, sorry. I don't know why it does this sometimes. It's probably because I'm writing too fast. Okay, what else do we notice? Well, we notice that segment BD is congruent to segment BD. I know this can sound a little repetitive, but remember this is the reflexive property. And this is one of the properties for congruent triangles, and it is useful for proofs. Okay, so what's the reasoning? It's the reflexive property. And this property states that any object property is congruent to itself. So BD is congruent to itself. So let's draw hash marks to represent that, like so. Okay, now what? Now you notice that it looks like we have two triangles, and you see the hash marks indicate side, side, side. So 3 sides of one triangle are congruent to 3 sides of another triangle. So by definition of the side, side, side postulate, these two triangles are congruent. So triangle ABD is congruent to triangle CBD. And remember, the vertices have to correspond in your congruent statement. Okay, and what's the reasoning again? Based on the side, side, side postulate. Remember, there are 3 postulates and 1 theorem we learned about. So 4 shortcuts in total. Okay, now what else can we know? Because remember, our goal is to prove that angle A is congruent to angle C for this isosceles triangle theorem. Well, remember, a corresponding part of congruent triangles are congruent. What does that mean? Well, AB for one triangle is congruent to its corresponding part, which is BC. AD is congruent to its corresponding part, which is DC, right? And this angle here, ABD, is congruent to CBD because those two angles correspond to each other for the 2 congruent triangles. And remember, our 2 congruent triangles, here's the first one, and here's the second one. Okay, so by definition, then we know that angle A is congruent to angle C. Angle A is congruent to angle C because congruent parts of congruent triangles are congruent. And we can write this in shorthand as CP CTC, which just states that congruent parts, whether it's a segment or an angle, are congruent to the corresponding parts, whether it's an angle or a segment, of the congruent triangle. Okay, so we just looked at the proof where angle A is congruent to angle C because 2 sides of a triangle are congruent. Now there's actually Okay, sorry. Okay, so let's just look at an example. This asks, what is angle B? Well, right away you recognize that 2 sides are congruent, and based on the isosceles triangle theorem, if 2 sides are congruent, then the 2 angles that are opposite from those sides are congruent. So here's the angle opposite from here, here's the angle opposite from here, so you know that these 2 angles should be congruent. So you know that this is also 50 degrees. But remember, our goal is to find angle B. So how should we find angle B? Well, remember that all triangles, all the interior angles of a triangle add up to 180, okay? So we know angle A plus angle B plus angle C should add up to 180. What do we know? We know angle A is 50. We don't know angle B, so leave that alone. And we know angle C is 50. And that's all equal to 180. So now we just solve for angle B. Just solve for angle B, which is 80 degrees. Okay. Now we just learned about the isosceles triangle theorem. There is actually a converse theorem. This is basically when you switch the 2 constituents of that theorem. So remember, if we go back, we said if 2 sides of one triangle are congruent, then the angles opposite those sides are congruent. So the converse theorem is when we just switch these 2 constituents. Okay, so it says if 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So you see how it's basically that theorem, but flipped. And I wrote this here. If the angles are congruent, then the sides opposite those angles are congruent. And this is what it would look like. Okay, so now we're going to look at 2 corollaries. So corollary, this is just a word for a statement that follows, These corollaries, these are just statements that follow the statements that we just talked about. Those are statements that already have been proved, right? Remember we looked at the proof right here? So the converse isosceles triangle theorem and the isosceles triangle theorem have proof. And because of these, we have two corollaries. So you can think of corollaries as a result of, right? So we get these two corollaries as a result of what we proved in the theorems, okay? So the first corollary is that equilateral triangles are equal angular, and vice versa. So vice versa is when you switch the two parts. So if a triangle is equilateral, then it's also equiangular. Or if a triangle is equiangular, then the triangle is equilateral. So you see how it's vice versa because we flipped it. So basically both are true. If you have this situation, then you also have this. If you start with this, then you'll also have this. And the second corollary is that each angle of an equilateral triangle is 60 degrees. So all angles have to be 60. Why is that? Because all of them have to have the same value because equilateral triangles are equiangular. And remember, according to the angle sum theorem, all three angles have to add up to 180. So if all three have to add up to 180, and all three have to be equal to each other, the only way for that to happen is if they were all 60. Because 60 plus 60 plus 60 is 180. Okay? So what did we just learn about? We learned about the isosceles triangle theorem, the converse of that theorem, which is basically flipping it around, and we learned about two corollaries, so two situations as a result of those two theorems we just talked about. And why are we bringing up equilateral triangles? Remember, equilateral triangles are actually a special type of isosceles triangles, okay? So that's why we bring it up. So let's look at an example. What is segment EF? What is the measure? Well, what do we notice? We notice that two of the base angles are congruent, so that means, based on the converse of the isosceles triangles theorem, then we know that the two sides opposite of those angles are congruent to each other, okay? So what does that mean? That means segment ED is congruent to segment EF, okay? And segment ED, what is the value of segment ED? It's just 3x, or it's represented by this expression, 3x. And we know it's equal to EF, and EF is represented as 4x minus 10, okay? So that's why we set it up this way. Because ED is congruent to EF, so they're equal to each other, and ED is represented by 3x, and EF is represented by 4x minus 10, where x is some unknown value. So now we just solve for x, minus 3x, minus 3x, so we get 0, because it cancels out, equals to x minus 10. Again, we need x by itself, so add 10, so x equals 10. So you need to be careful, because what does x equals 10 mean? You have to understand what your answer means. So Apex might try to trick you by having you see that 10 is the first choice, and you would automatically think it's the right answer, but that's not the case. That is not the answer, because you have to think about what x equals 10 means. What does it mean? X is just some unknown, represents an unknown value, where if you plug it in, then we'll get the value of our segments, okay? So let's plug it into here, 3x, because that seems easier in my opinion. So 3 times x, where x is 10, gives us 30. So our answer is C. Now, does it matter if I plug it into 3x or 4x minus 10? No. In this case, it does not matter, because what did we say in the beginning? We said that segment ED is congruent to segment EF. So whether I plugged it into here or here, I'll get the same answer, because these two are congruent or they're equal to each other.